Okay, so welcome to session 6 for the Cloud Mentorship Program. So today the focus will be on three key concepts. The first one is actually the VNF and what is the internal architecture of the VNF, how the VNF is being modeled, and how the VNF is different from any application, monolithic application or IT application. And then we will take one step further, and we will give an overview about the concept of containers. And most probably it will make more sense to talk about containers after we talk about the VNF to catch the sense of evolution. And then the last section will be about the concept of cloud native. I'm sure we all hear the term cloud native, so I'll try to put a definition and actually assess the concept of cloud native map to what we are doing in our corresponding domains. So if we are fine, I would like just to start with to take a review or to remind you all of the classic HCNFV reference architecture that we had in one of the sessions before. And we were focusing on the NFVI, and then we know that on top of NFVI, the VNF is onboarded, and the term V comes because of the fact that these network functions run on a virtualized infrastructure. Then that's why we call it VNF. So it goes from the NF, network functions, classic network functions. Sometimes people say PNF, physical network function, to VNF. And also we defined that a functional box, which is the VNF manager. And we said that VNF manager is responsible of the lifecycle management of the VNF. So it is responsible of the instantiation of the VNF, scaling, healing, termination, and these kinds of things. So if you are okay, and we all remember the architecture, and we are ready to go to the VNF, we can go confidently to the second slide. So the first one is a definition, and the definition comes from HCNFV, and it's a logical definition that VNF, it is an implementation of a network function, a classic network function, that is deployed on an NFVI, on a virtualized infrastructure. So you should expect that these VNF would run on servers with hypervisors, and these hypervisors are creating some sort of virtual machines, and these virtual machines are carrying the network functions in a way or another. The new concept, or the concept I want to stress on, is the concept of the VNF component. And before I talk about the, sorry, is there any questions? Okay, if not, then I will just thankfully ask all of you to just to put yourself on mute. Okay, so the concept of application, or let's go to the classic definition of an application. And let's take the IT, for instance, as a reference. Think of any application like a web server, for instance, a database, any kind of IT utility. Usually, when you talk in an IT concept, and when you say VM, usually this maps in IT to an application. Why? Because usually the IT application is a VM, what we call it a monolithic. Monolithic application, this means that it doesn't have subcomponents. So if it is a web server, then it is a web server. If it is database. So it is monolithic, okay? Single function or single component. But usually people working on telco, which actually most of us, we know that our network functions are complex by design. So it includes different components. You will find under the name of one network function, there will be some components working to do control plane handling. Some are doing user plane handling. Other components are using, doing transcoding. Other components are doing IPsec termination. And that's what brought the concept of VNF component. And when you understand the concept of VNF component, and then later the concept of microservices, you'll find a lot of similarity. So VNF component, by definition, it's an internal component of VNF, providing a defined subset of the VNF functionality. So if we agree that for example, a node or a network function like the classic 4G gateway, which is the P gateway. So P gateway, it has a user plane termination or user plane handling. So there should be a VNF component doing the user plane handling. It talks with the S gateway, with the MME, with the PCRF, with OCS, with some sort of a control plane. So there's a component dual control plane. It has an O&M capabilities. So it has also component, VNF component doing O&M. So you end up with one VNF in telco that have multiple VNF components. Okay? The VNF components, at the end, each VNF component, for instance, if an operator requires a gateway to handle 100 gigabit per second throughput. Okay. So there's a VNF component in that P gateway that will do this kind of throughput handling. But how many instances of VNF component? That's the dimensioning part, and that's what comes the term. That's what brings the term VNF component instance. So the VNF may have a VNF component that does the user plane handling, but to process or to handle the required throughput, you need 4 instances. You need 4 VNF component instances. And you will find that later you'll know that these VNF component instances is basically the VMs. So you need 4 VMs of that specific type to handle 100 gigabit per second throughput. And you need 3 VNF component instances or 3 VMs from that other type to do the control plane. And then 2 VNF component instances from 2 other VM types to handle the on-them. And that's what construct at the end the modeling or the dimensioning of the VNF that I'm going to show in the next slide. I'm just admitting the colleagues as we speak. So people. So the VNF component instance, okay, usually, as I said, it's a VM, okay? The term that described the VM at ECNFV, that was a standard term that they used, is called virtualization container. Virtualization container, that's the standard name. But at the end, think of it as a VM, a virtual machine. So if you see my cursor now, think of a virtual machine that has Linux operating system or any kind of operating system, okay? Do you think that this VM with Linux operating system works by default as a media gateway? For sure, no, right? So it may need some sort of a software instance or some sort of operating system that make this VM behave as a UGW or a P gateway or an MME. So whenever you have the virtual machine and it has this software instance that actually allows this VM to perform as a subset of the VNF functionality, for example, doing control plane processing, transcoding, IPsec, you can call it VNF component instance. Why I'm saying that? Because when you open what we call the VNF descriptor, the modeling of the VNF, you will see all these parameters. Okay. I will go to the next slide and then I'll get your question just to complete what I want to convey. Okay. So in the next slide, you will see a logical or an architecture diagram showing how the VNFs are being modeled. So if you want to interpret this kind of diagram, you will say that, okay, this is a VNF. Let me have a laser, maybe. This is a VNF instance, let's say an X gateway, whatever its name. And it has 2 VNF components, one doing the green function and one doing the yellow function, one doing user plane, one doing control plane. And as you see, the VNF component, the green one, we have 2 instances. So we have now 2 virtual machines from the green one and 2 virtual machines of the yellow one. And it seems that these green ones are interconnected together, if you see this link. And if you see this red thing, as if the modeling is trying to tell you that these VMs, they have a network interface card, they have a port, network port, and these 2 VMs should be connected through a virtual link or through a network, maybe layer 2 domain. So this is just the drawing, what the drawing wants to tell you, that these VNF components, the green ones, they have NIC cards like the server, because we agree that VMs is like the server. So it has a virtual NIC, and they are connected together. And another thing that we can interpret, that these two greens, one, can have external connectivity outside the VNF using some sort of an external exit point or external connection point. So we read from here, we have two VMs of the green type. They are connected together, they can communicate together, and also they have access to outside the VNF. The same thing about the VNF components in the yellow, that they are connected together and they have also external connection point. If I may interpret this diagram without much information, I would say that if the yellow component wants to communicate with the green component, it seems that internally this is not permitted. They have to communicate through external networking or through going outside the DNS. Okay. The connectivity between the two VMs, we call it internal virtual link. The external connectivity of the VNF, we call it external virtual link. The connection point or the networking interface of the VM or the VNF component instance, we call it internal connection point. And the external of the VNF, we call it external connection point. And guess what? If you go to a VNF descriptor, a modeling template for the VNF, you will find it written like that. We have two VNF component instances. Each one have this kind of internet connection point. They are connected like that. So we should expect that at a certain stage, there is a brain in the stack will take this modeling template and understand what is in that, and then communicate southbound to OpenStack, to whatever system in the Vim or in the infrastructure manager, and talk with that Vim with the language that he can understand. And then you will see that this kind of modeling is actually realized on the infrastructure. So this will come when you see the flows. But now I just wanted to understand the difference between the VNF architecture to an IT application. Most of the IT application are monolithic. We have multiple components. We are complex by design, okay? And each VNF component are doing its own specific function. The architecture of the modeling of the VNF, you define exactly what are the VNFs and for sure other metadata. I will stop here, and then I will have some questions from your side, and then I will go with a practical example on how we map these kind of concepts with the dimensioning. How many VMs we need, how many CPU do we need, this kind of things. So let's see the question. Is a VC mapped to a single VM or multiple VMs? Yes, the virtualized container, it's one VM. So you can, just to make it easy, a VNF component instance, it's a VM with a software that makes the VM work as planned, as a VNF component. So VC, virtualized container, in ITSI terminology, it's a VM.
Karim, I think in 5G it's different. Like the component is light and it's based on microservices, and the function is very light. So I think in 5G, and correct me if I'm wrong, in 5G, the one function of 5G, like UBF, MF, whatever, will be represented in one VNFC, right or not?
No, it's not like that. The only difference is that the VNF component instance will be carried on pods or containers, not on virtual machines. But still, you have these different VNF components. But because of the evolution, you will see that you will be called microservices. Okay, but still, the UPF or the MF, no, they have multiple VNF components doing different stuff.
So even after the separation and the evolution of COPS and then 5G, still the component is complex enough to be many components, right?
Yes. It's very difficult to find a monolithic thing, and even if you find a monolithic thing or one VNF, this will not be a good approach, and I will explain that in the cloud native part. I mean, when you understand the cloud native guidelines, we will see why it's not recommended to put all the logics or different logics in one instance or one VNF component.
Okay, great. Thank
you. Okay.
Karim, I have one question related to that deployment. If we are going to save it in file or something like this, I believe like image or repository to institute that VNF. I believe this is the Tosca file, right? Or yeah.
Exactly. The one that I was referring to, the VNF descriptor, it is written in Tosca format. It has the .yaml extension, and that's what actually the VNFM reads at one stage, and then interpret what is inside, and then communicate to the OpenStack, for instance, classically, to deploy whatever it takes to realize what is there in the templates. Okay.
Agreed.
Karim, I have one question, please. Each VM requires a guest operating system. Is it proprietary operating system or CentOS or Linux operating system?
Okay, that's a very good question. So I saw two techniques, two types. Some vendors, they have a guest operating system proprietary. You boot the VM, it gets the operating system, it works as an IMS node. And embedded in that operating system, for sure, it might be Linux stuff, but on top of that, there are some packages or libraries from the vendor. Okay. There are other technique that I saw that you boot the VM from classic operating system like Linux or whatever, and then as a day one operation, a post operation, you go and get another operating system FTP, and then you run it, and it goes like two stages, like as if you are putting an operating system for the host, for the foundation, and then you deploy another package separate to make this VM behave as a whatever radio component or IMS component. But usually it is a proprietary guest OS.
Yeah, thank you.
Okay, so let me show you the relation between a VNF and the NFVI and how the operators are doing the dimensioning and how they understand what kind of resources should they avail for a VNF. So usually in the RFPs or this kind of RFQs or RFX, the functional team, the one that owned the VNF, for instance, this is regardless what is S gateway, I just put a letter. This is not a security gateway or even any gateway. Usually in your requirements, you don't say that I need 6 VMs or 4 VMs as an operator. What you say is that I have this traffic profile. I have throughput at the video hour. I have attachment, transactions, any kind of data that describe your traffic profile as an operator. And you want to procure a node or a function that would serve your requirements. Okay, but since this the requirements now are fulfilled by a virtualized network function, not a physical one, so the vendor who is providing the VNF should tell you exactly what are the resources needed to cover your traffic profile. So, for instance, you give Ericsson, Huawei, Nokia, you tell them, I need to cover 100 gigabit per second, 22K transactions per second, 1 million SAU, simultaneous attached user, whatever parameters you give it to the vendor, and then the vendor will come to you Nokia will tell you, okay, you know, my VNF has 3 components: user plane, control plane, and management. In order to cover your requirements, I need 6 VMs from the first type, 4 VMs from second type, and then 2 VMs from third type, which is the blue, yellow, and the green. And maybe Huawei would come with different dimensioning because of the different architecture. It can tell you, I have 4 components, not 3 components, and I need maybe resources less than that. So at the end, as an operator, you get the resources requirements from all the vendors. Usually you dimension on the maximum. And then you end up with that I need this number of CPU, this number of disk, this number of memory. Because anyone who's telling you I need number of VMs from that VM type, the word VM type is what we call the flavor. What is the flavor of the VM? And the flavor of the VM is what is actually the CPU and the memory and the disk. So at the end, you map your traffic profile to a number of VMs, and this number of VMs have different profiles or different flavors. So you get the overall requirement of the infrastructure you need. For sure, as an operator, you can put some sort of a safety factor. You can multiply by 1.2, 1.3, just to account for any kind of future expansion or any kind of anti-affinity requirement that maybe some VMs are required to be placed in different servers. You need to increase the servers, but that's more or less the relation between a VNF and the NFVR, how you do the dimension. Okay? Are we okay?
Yes.
Yes.
Okay. Thanks. So that was the first part. And you will see many similarities when you go to the containers. And let's now go to the container. So again, this is not a classic Kubernetes training course, but I just want to reach a logic that would enable us to understand any kind of related concepts. So before I talk about the container, let me shed some light on the container image, okay, or the term image in general. Okay. So classically, if you want to install a new app, people coming from the 90s like me, we used to have a CD or any kind of drive that have an exe file or have an application or an image. Usually, what would you do? That you simply put the CD and then you run the image, okay? And when you run the image, you start to get, you know, the application, the dependencies. You start to have a logic that you may use as an application. So the starting point is not actually the container. The starting point is the container image, okay? So usually, if you think or any application or any function that is being developed by a developer, let's think of any, you know, C++ stuff, any function that does plus or minus, basic one. So any developer who's developing an application, if you ask him about the containers, or he doesn't know about the containers, he doesn't care about the cloud. He only focus on his code. So you need something at the end to actually translate this code or to map this code to an image that can be executed and then, you know, triggers the launch of an application that corresponds to his code, to her code. So usually it starts with a developer coding an app, coding a logic, and then a question may rise how this code, okay, would go and be a program at the end. So you need to run, you need to compile, right? But at first you need to package. So the container image, as you see the definition, and I like always to read the definition after the explanation. So now if you read the definition, so it's a lightweight standalone executable package. So it's an executable, something going to be executed of a software that includes everything needed to run an application. The code, which I was talking about. So you need to have the code, but also you need to have runtime and system tools that will help this code to be compiled and then come as an application. So you will find, when you see the slides, the coming slides, and even in your work, when people start to talk about CI/CD and DevOps, there is always an important stage where the code and other files, arbitrary files, are being packaged in an image. So this is a very essential step in any pipeline. So it starts with the container image. So usually, if you ask any vendor about, like, give some details, provide some artifacts about your CNF, he will give you the image. So that's the starting point of the container, to have the image or the container image. And I will start to use the term C now. So I will use CNF instead of VNF. And just to avoid any confusion, HCNFV, they are still using the VNF term, and it's fine. But the community is using the CNF term. And CNF term, it has two different interpretations. Either it is containerized network function, so it is network function based on containers, or cloud native network function. And most probably cloud native network function is also based on containers. So both of them are more or less the same thing. So the CNF, the starting point is actually the container image, is that we have the code and runtime, some tools are packaged in a container image. This container image, when it is executed, when you run this container image, you get the container. You get container runtime, or you get the app, you get the logic. Okay? So container, from definition, it's a lightweight, isolated, self-contained execution environment. And that's the important thing for me, that it is a self-contained execution environment. You can find multiple containers sharing the same host operating system, sharing the same Linux, but each one of them is a separate execution environment. And that's what does somehow the isolation between the containers, because in virtual machines, it was a very explicit isolation. Hypervisor used to create virtual machine. Each virtual machine believed that it's a server, okay? And the way virtual machines are interacting with the host operating system are actually governed by the hypervisor. But virtual machines, they don't share the operating system with each other. Like what Abraham was saying, each VM has its own guest operating system. But here, the main difference is that container, they share the same operating system, but because they have a self-execution environment coming from the container image, they have a sense of isolation. Okay? So the main difference. Yes, please.
Can I ask a question now? Or
Sorry?
Yeah, so I have this piece of, remember this software, the green part in the VM, this does not exist anymore in the container concept?
Sorry, Wes, I don't hear well. Can you say it again, please?
Yeah, so the container does not have this green piece of software that we show it in the previous slide on the VM.
Yes, exactly. The technique is different. So there is no software like guest operating system in the container. No, the container share the same host operating system of the server, actually, which is classically might be Linux. So all the containers, they share the same operating system. They don't have specific guest operating system. But the only thing here that guarantees somehow that the container A is unique and different from container B, that it has its own libraries, its own execution environment, because it was packaged differently. Okay, does it make sense?
It will hopefully with the coming slide. So thank you.
Okay. I'm just explaining the concept of container. When you go deep a little bit, when you see how they can construct maybe a CNF or a logic in a telco, maybe it will be more related to telco, but now it's just a concept of a container image and the concept of a container. Okay. Another concept is that usually if you're someone working with containers, even working with in telco, in 5G, you'll find most of the professionals are talking about the pod. Okay. So pod as definition is actually that's a small compute unit that can be defined, deployed, and managed. So usually we work with pods. We say that, for instance, to do the control plane processing, we need 3 pods, 4 pods. We don't say 4 containers. Classically, the pod is one-to-one with the container, so the pod encapsulates the container, but it exists also in the, maybe I didn't say it in the telco, but it exists as a concept that one pod can have 2 containers. There are some use cases, but I didn't say it in the telco. But from now, if you remember the term VNIC, this kind of thing that was closely coupled with the VM, we say that VM has a VNIC, right? Like server has a NIC card. So VM has a VNIC. When in the containers, we assign this interface, or we talk about the interface on the pod level. So we say pod has an interface, has secondary interface. We don't say containers have an interface. So we will always talk about the pods. Okay. So that's the concept of the pod. And you will see in the templates, that define how this CNF is constructed, you will see an explicit definition of the pods in terms of resource requirements, in terms of number. So it's very similar to what we used to do to VNF components in the VNF descriptor or in the classic telco cloud. Another concept I would like to talk about, which is the replica set. And the replica set is something that guarantees that the container platform, let's say Kubernetes or whatever, ensure always that the number of pods are preserved. What does this mean? If I define that the VNF component or the CNF component or the pods that process the user plane should always be 4 pods. I'm writing that in the modeling that these type of pods that handle the user plane should always be 4. So the replica set here is 4. Okay. So what happens if a pod is crashed or is down? The platform itself, because of that setting, instantiate a new pod and always ensure that the number is 4. And that's one of the beauty and the good things about Kubernetes or about containers, that this kind of healing scenarios that we used to suffer from in the VM world or domain is implicitly and explicitly covered by the container platform solution. So the replica sets are preserved by the container platform. It always watches the status of the pods. If one pod is down, it may instantiate another one to make sure that the pods are following the replica set configuration. Okay, and this is something done by the cloud platform itself, not by the MANO, NFVO, and these kind of things. Another concept, which is a daemon set. If you define in the template that this pod is a daemon set, then most probably you want this pod to be instantiated on all the nodes. So if we assume or we think that a cluster, Kubernetes cluster may consist of control plane and workers. Workers are similar to the compute node. These are the servers that will run the application or run the workloads. So for instance, if we have a cluster of 10 workers, 10 servers, and we say this pod is a daemon set, this means that this pod will be instantiated on all the servers, on all the workloads. For sure, you can do some selective choices, but the default is to have this pod running on all nodes. And this is very common if there is a function, for example, if you need to collect the logs from all workers, and the one responsible to do that is a specific pod. So you define this pod as a daemon set, and you find this pod deployed on all workers. So container image, container, okay, pod, replica set, daemon set. 5 concepts, 5 foundational concepts. One of the, please.
So the replica set is something like a backup for the pods. If one pod crash, it will be a backup for it, or
No, it's not a backup. It's actually, okay, you as an operator, you want the vendor to cover a specific throughput and transaction and whatever. So the dimension was that to cover your traffic profile, I need 4 pods of this specific type. Okay.
okay.
If it goes to 3, there will be an impact in the service itself. That's why we need to ensure that the pods are 4. So you define replica set to be 4.
Okay. And the daemon is something like logs collector or something like this, right?
Yeah, something like that. And it's but this is a use case. It can be anything else. But the concept is that if it's a daemon set, then it will be instantiated on all servers, on all worker nodes.
So this means that if we have a 4 pods for the replica set, and I have a daemon set, it will be in every pod. No.
Let's separate. Okay.
Okay.
Let's see that you have, for example, a certain function or a component of the CNF. To be run, it needs 4 pods of a specific type. Okay. These 4 pods, physically, they can be on one server. They can be distributed in 4 servers. Maybe 2 of them are one server, two of them are on one server. So physically, it can run anywhere. Okay.
Okay.
You agree? But if it's a daemon set, it will run on all servers. For example, if you have 10 servers, then you will have 10 pods, a pod on each server.
Okay. Okay.
Karim, can I ask you, what is the definition of node here? Is it a VM?
The node here is the underlying infrastructure. It can be 2 things. It can be a physical server, or it can be a VM. If you are running your container cluster on a virtualized environment. But that's a little bit complex setup. So let's keep it for now. This is a server, a physical server.
Okay. And I have another question, please. The daemon set, what is the use of the daemon set concept to have running my pod on all the nodes, available nodes?
Okay. I will reply to that and also to Sharif's daemon set point. So the use case classically for the daemon set is the pods or solution that rely on specific pods to get the logs. So each server generates logs. And you need a pod on each server to get the logs and then send to some sort of an umbrella or a unified logging collector. So usually it works in the monitoring when we need some capability on each server to extract the logs. So that's the classic use case of a daemon set. The other question, Sharif is saying that this daemon set will be independent pod or deployed within all existing pod with other container as a sidecar. It's good that you mentioned sidecar, Sharif. So sidecar, usually it is like a container that providing supplementary function for the primary container. And if we go one slide back, you see this pod that has 2 containers. A classic use case is to have a primary container doing the exact function, and some side.
Apologies, Karim.
Yeah. Karim, your voice is breaking.
My voice is breaking. Is it good now? Hello? So you can't hear me?
Yes, Karim. It is breaking.
So, okay, but not, okay. Can you just give me 1 minute? I'll be back.
أمجد كيفه؟ الله يعطيه العافية.
Hello. I hope you can hear me now.
Yes, you can hear well. Yes, now is much better. Karim.
Okay. So let me try the cam. Okay.
طبعا مخلدان ربات مش كلش سيرة. اللي ما اعطيناهوش لمجدي هذا.
So
هنيت لفهيد.
we are back. Could you mute yourself, please? Okay. So you see me now, right?
Yes, yes.
Yes,
Yes,
Kareem, now.
we can.
Okay. So I was explaining the concept. I mean, Sharif mentioned a term, which is a sidecar. Okay. If you see the question or the comment that let me bring it. Yeah. So the daemon set will be independent pod or deployed within all existing pod with other container as a sidecar. So usually the cases where you can have maybe 2 containers in one pod, you can have a primary container doing a primary function like some sort of traffic handling or whatever, and a sidecar that is doing supplementary service for that specific container, maybe collecting logs, doing some stuff. So that's a sidecar. But daemon set, no, daemon set is very independent. It's not related to sidecar, a sidecar, and it is independent deployed on all nodes or on selected nodes. So we move from daemon set to a very nice concept that actually makes our life much easier with container, and that's why we now start to embrace the cloud native stuff. So in the old days, the virtual machines in the concept of a telco cloud, it is a very important. It's very important to preserve and keep track. And if one VM is down, this is actually something that most probably operations will be involved and all parties will be involved, because we used to treat the VM as a pet. Like we have to keep this VM stable and healthy. In containers with the concept of service, okay, usually, for example, think of a control plane processing. So, and you are exposing a control plane service to the outer world. This control plane service is being processed or handled by underlying pods. These pods can be 3, 4, 5, 6. So the service itself is exposed as a concept of service, while the pods are something on the back end. So if one pod is down, for instance, and the other 2 pods can do the function, the service is still up and running. Okay. And if for some reasons you add another pod, it gets discovered automatically by the service and is being added automatically to serve that specific service without any interruption to the service itself. To an extent that we don't care a lot about the pod's IP addressing compared to what we used to do in the VMs, it gets an automated IP address pool, internal pool of the Kubernetes. So control plane now is a service. You don't care exactly where are the pods are located because the service can discover where are these pods and do this kind of mapping or whatever external customer requires to how the internal pods are contributing. So with that theme, or with that context, we don't care a lot about the pods. Why? We have the replica set, so we are confident that if one pod is down, replica set will instantiate that pod. It's like a policy. We don't care a lot about where the pods are positioned, because if they are anywhere in the cluster, the service will be able to discover these pods. For sure, we can control where are these pods are located, because we are telco guys and we want to make sure that we see everything. But as a concept, these pods can run everywhere in server 1, server 2, server 3, server 4. So that's the concept of service. It exposes the business logic or the service logic or the functional logic to the outer world. It does service discovery on the underlying pods, and for sure it does the load balancing on these pods. Okay. Having this service, and we stop at that service, that's an internal concept. To make this service exposed to the external world, we get the concept of ingress, and that's where I will stop. So to have this service routable and accessed by the external world, we define something called ingress, and that ingress puts rules that actually expose that service to the outside world. So as you see, we don't care a lot now about the pod the way we used to talk about the virtual machines. The concept is nice and light, but originally, if you think of a VNF component and the VNF component instances, there are some similarity, but for sure here the maturity of the cloud platform solution and the idea of having auto instantiation or auto healing and auto service discovery, that's a very advanced feature of containers and the containers management platform. So quickly, we started with a container image. Okay, something that package the code and the runtime and all the dependencies. Whenever it is being executed, like we use to run exe files or any kind of installation files, we get the application, we get the container. The container itself is wrapped or is incorporated in a pod. That's the smallest compute unit that actually we deal with. Component maps one-to-one to pods. Pod 1 maps one-to-one to container, or 1 to more, 1 to n, or 1 to 2 in most of the cases. We said in telco, other than the sidecar case, we are used to one-to-one, which one container and one pod. The pod itself takes an automated IP address, so it's not like the VM. We care a lot about the IP addressing. You have the pod by itself contribute to a service, but the service is announced, or the service is exposed by the concept of a service. But before that, you define in the template, on the way you model your application, what is the replica set, what is the number of pods that you want the platform to govern or to make sure that it is running. That's the replica set. And also you can specify this pod in the template as a daemon set, and if you do a daemon set, a deployment of a pod as a daemon set, it will run on all nodes or on selected nodes. And nodes here are the physical servers. The most wonderful thing that we all love about the containers is the concept of service, that you don't care about the pods. You expose control plane or user plane, IPsec, whatever service, or HTTP, any kind of service exposed, and underlying this is backed, or the actual traffic are processed by the pods. Service auto-discover the pods, doing internal load balancing. And if you want to expose this service to external customers or external entities, you do that by the concept of ingress, which is actually some sort of a control for the traffic routing. These are the concepts. Any question before we go a little bit on the cloud native practices?
Yes, Karim. Here, if in which level we are guaranteeing if we talk about the service, in which level we guarantee the redundancy and geo-redundancy concept? Is it
okay? So it's a good question. So service is one, so it's a logical entity exposed to the outer world. The pods itself, we have means to guarantee the HA and the DR and whatever mechanism you want to preserve for this application. So you can say that these pods shouldn't run in one server. So by policy, you put these pods in different servers. So if one server is down, you don't lose all the pods. Okay, so you control you control the placement together with the replica set that guarantees the service continuity.
Okay, so it's in the policy of.
Yes.
Okay, so you can decide if it's highly available or even in other region like a DR where it's running.
Yeah, but it's not written explicitly HA or DR, but you control the placement of the pods, and the way initially you are building the cluster. For example, some clusters they have a DR by default, so you have a primary cluster and a secondary cluster. So you distribute this application on these two, and you control what is actually the DR mechanism. So there are a lot of variables that you can control.
So from the creating of the creating of the clusters at the beginning when you design it, so you can.
Yes.
Okay, clear. Thank you, Karim.
Karim, regarding the ingress, what is something like a small load balancer for the service, and it's load balancing the outer request to this service, it's a different container or different pod, right? So
yeah, it can be seen like that, but usually the ingress here is just we call it a router, just a router.
Okay.
You may have load balancing as an extra feature, but it's classically a router.
And regarding the distribution of the load over the pods, it will be like round robin, or we have a control on this? Can I increase
no
the load on one pod and decrease?
No, you don't have, and this will be too much control, which we want to avoid.
Okay.
This will contradict with the cloud native concept that if you go into these kind of details, then you will lose the cloud flavor.
Okay, agree.
And Karim, now we need two kinds of VNFM and or CNFM and the containers orchestrator or controller as well. So like Kubernetes or something to control the container and something to control the CNFM itself.
See, now there are a lot of similarities between what the Kubernetes is doing and what the classic VNFM is doing. So it's a gray area in the industry. But we can have like one session, but maybe not this month, when we are assessing some telco use cases. So, but as a general note, yes, you may have two entities like CNFM or VNFM and Kubernetes, but you will find a lot of common things that you do together. Me personally, I have maybe different opinion of the necessity of having a VNFM, but for the time being, the CNFM or the VNF managers, they are the ones who actually hold the artifact of the image itself and the configuration file, but that's a little bit too advanced. But most of the flows that the VNFM used to do in the classic HCNFV stuff and the infrastructure as a service and the VM domain virtual machines, it's being done by the Kubernetes. Okay.
Hello, Karim. I have one additional question. I don't know, maybe for today or for any other day. It's about, for example, the 5G network functions, because you know that some of them are really traffic sensitive. For example, UPF, user planning function. For that kind of function, are we talking about pods or pods or container? And the other thing is, how do you define that kind of functions in this cloud system? Because, for example, today, maybe you have one user just consuming, like, I don't know, 1 Mbps, but tomorrow you will you will have, I don't know, like 10,000 subscribers and consuming maybe 1 terabits per second or something like that. Are these a concept of, for example, for UPF is more related to container or to pods? And how is it growing based on the traffic or the user? Are you creating container every time you add more traffic and more user over there? Or you just create one container for example, for the UPF, and then make some replicas or just grow, or how do you handle that kind of function? It's like my main question.
So the same way the vendors used to dimension traffic profile and project that into number of virtual machines and VM flavors, they are doing that on pods. So they will come to you and tell you to support your traffic profile, the gigabit experience and these kind of things. You will need 6 pods. But with the innovation, now one pod with a lightweight, with low resources, can process, really very decent amount of traffic. So there is also an innovation and evolution of the capacity of the pod itself. Okay, so you don't expect that to for example, to process 300 gigabit per second, you need like an army of pods. No, it will still be a good number of pods, like 6 or 7, according to the CNF architecture and the VNF. But at the end, you will get the dimensions in terms of pods. So they are pods. But the good thing is that if traffic goes, the scale out is a native process to Kubernetes or to containers. So if the load increases, the pods are not, more pods will be instantiated, and the smart thing is that service, it is the same, so you don't need an administrative intervention. Okay, we didn't see till now, maybe with 5GSA and maybe with the I would say the huge increase in throughput, maybe we will meet limitation. But currently, the first generation of 5G core, and with the fact that there is a lot of distributed techniques, so you don't put one UPF to cover the 5G throughput of the nation, right? So till now it is handled, and I didn't see any complaint from a capacity perspective.
Okay, thanks a lot.
Karim, do we still have the same concept of flavors like the
Yes.
OpenStack?
Yes, we have it, but on the pod level.
Okay.
Okay, so quickly, and in 15 minutes, since we talked about containers, let's just assess the term cloud native. What does it mean, and how we map it to what we were discussing. So cloud native is a very term buzzword that have multiple definitions and multiple contexts, but I try to cover like the main contributors, the main elements contribute to a cloud native practice. So in telco, using containers, something called microservices, something called S2I, source to image, automation, orchestration, DevOps, DevSecOps. Many of these terms, whenever it is being placed, it refers to a cloud native practice. So usually professionals, LinkedIn, vendor suppliers, whenever they talk about these kind of concepts, they refer that to a cloud native practice. So I try to group them. So let's take it one by one. So if you are developing your application on set of independent deployable modules, like the old VNF component, but you do it on a microservice with a very small size, small footprint, that's a cloud native practice. Think of a UPF 5G core user plane function. If you do it in a monolithic virtual machines, it will be a giant virtual machines that has all the logics. And if the VM is down, then control plane, user plane, transaction, IPsec, whatever, all of these are down. So it's not smart at all. So if you develop your application as it's based on a microservice, like a microservice, group of pods doing control plane, another group of pods with another personality doing user plane, a third group of pods with another personality doing transcoding or whatever, that's an act, or that's a practice of being cloud native. These microservices 100% coupled with containers. So when you say microservice or pods, at the end, they run in containers. So using the containers, containerizing your application from VM to containers is an act of, or a practice of being cloud native. When you apply zero-touch deployment and configuration, when you apply dynamic lifecycle management, scaling, healing, instantiation, upgrading, all these are practice of cloud native. What does it mean of zero-touch deployment? That you can just go at any time to your portal, and in the portal you say, create or provide me an cloud cluster or Kubernetes cluster. You do this, and in no time you get the cluster up and running. So you have the right automation workflows and automation tools on the background fulfilling whatever you requested. So these kind of things are practice and acts of being cloud native. Capability to produce container image from source code. You will see that most of the operator or most of the enterprises that has in-house developers and they have their own applications, they have a very strong pipeline, and I will explain what is a pipeline. That starts with a coder or with the developer doing some code and ends with a container deployed on a container platform. So in the middle, there's a capabilities to provide container image from a source code. And then applying the DevOps and DevSecOps practices, and we will have one session about that. Whenever it is there, that's also an act or a practice of being cloud native. So these are all like the factors that actually maps or that are projected into the definition of being a cloud native. Just to stress on the understanding, let's, even without having a huge foundation, let's just think logically about the following statements. And I'm here reminding you of the cloud characteristic that was defined at 2011 with the NIST, an entity in the US, National Institute of Standardization or Standardization of Technologies. So they put some definition of the cloud characteristics. So cloud should be on demand, self-service. So at any time you can get your service. It's a broad network access. You can access the cloud from anywhere. It had the resource pooling. So not a single function capitalizing on a specific hardware. So all resources of the cloud are being shared. And it is rapid elasticity. It can scale out, scale in with in an automated way. And measured service, that, for example, if you consume specific CPU and memory, you get this kind of measured, and then you do the billing the same way, for example, classically Amazon is doing, or you think of it from telco perspective, measured service maps to the service assurance part. So let's take it one by one. So the application supplier insists that application must run on a specific cloud infrastructure. I'm a vendor X. I'm telling you that my application X should only run on the cloud X. Does this make it a cloud native? You can for sure, you can reply on the chat. So for sure, this is not a cloud native, even without having a huge foundation on what is cloud native. Cloud provider plans to migrate all applications to perform software upgrade. So imagine that you have a cloud that has like 10 network functions, and there is a cloud upgrade. Do we need to migrate all the applications to do the upgrades and then get them back? It's happening in the telco for some reason, but this is not a cloud native practice for sure. The application supplier telling you that we don't support auto scaling. So if the traffic increase, there is no way that so this is not for sure a cloud native. Every time you scale out your network function, you need to update the IP addressing manually. And that's what the first generation of the NFV. Whenever we add a VM, we used to do the IP addressing manually. But for sure, as I showed you, we don't care. We don't care a lot about the pods IPs. So every time it scales, it gets populated automatically. VNF is based on virtual machine. Okay. Each VM requires 38 vCPU with CPU pinning. This is not a cloud native because cloud native is lightweight by default. I mean, the application itself. So a VM with 38 virtual CPU, that's a huge thing. And with CPU pinning, that's a very, a very aggressive thing. So that's the classic telco workload that we saw at the beginning of the NFV, and this is not a cloud native practice for sure. VNF components must run on specific host with specific configuration. This is happening, and this is not a cloud native practice. What does this mean? For instance, you may have some servers that have, for instance, strong capabilities in terms of network interface cards, in terms of networking. So that you put the pods or the VMs related to user pin handling on these servers. So you do that because you need to do that to consume the capabilities, the strong capabilities of networking on the server. So sometimes, and this is happening on the telco, you explicitly mandate the placement of VMs into certain servers. This is happening, but it's not a cloud native practice. Yes, exactly like what Iman is saying, like SRUV servers. For instance, some servers are dedicated for SRUV, which is a feature that allows the virtual machines to leverage the physical NECs directly in a way or another. So you need to put these VMs in these specific servers. Our app supports scale out, but scale in is not supported. So you can scale out, but if the traffic is reduced, you cannot go back. And this is most of the telcos, unfortunately, telco VNFs are like that. So this is not a cloud native practice. So think of a cloud native as the counter or the opposite of these statements. So whenever you do the opposite of these statements, then you are doing a cloud native thing. We run on containers, but we need a dedicated Kubernetes cluster. And by the way, this is the current pain point that we are facing now. Current problem that some of the telco vendors, they are now running containers, but they prefer, for some reason, to have their own cluster and not to share the cluster with any other CNF. Okay, so I will end with these two slides, and then we can continue next time. So, okay, now I need you to focus. We talked about microservices, okay? We talked that any classic network function can be developed into a basis of a microservice. And microservice, the blue, it can do the control plane. Microservice, the green, it can do the user plane. Microservice, yellow, transcoding. Purple, IPsec termination. And red on them, okay? And to have like a cloud native architecture, these microservices should be stateless, shouldn't store the state or the information on its own, because we don't want to care a lot about the microservice the same way we care about the VM. So the state itself, the information of the customers or whatever session is being handled, is being stored on the database. Okay, so if you reach this kind of innovation or evolution in the telco network function architecture, you will have something very nice that at a certain stage, each microservice will have its own pipeline, its own developers, its own business units doing their own innovation, upgrade, bug fix, independently and isolated from the other team doing the other microservice. So it is one network function, but since it is based on microservice, then the BU that is actually taking care of the control plane or transcoding can work freely, independently, doing development for a software package for that red functionality, while the other team, the other BU, although it is the same network function, but they have their own pipeline doing development, upgrade, and bug fix of the purple one. And this actually reached a very aggressive and nice mode and the IT, where even the IT administration or the cloud administration, they stop talking about application. They talk about microservices. So he knows that there's a red microservice and the purple microservice. and he doesn't care a lot about what kind of application do this microservice belong to or contribute to. You imagine the act of sorry, it's Ramadan, we are fasting, so I will find the word. So the disaggregation of microservices had reached a very mature level on the IT where they only work with microservices. In telco, we understand that our CNF consists of microservices, but at the end, it contributes to one CNF. For example, we will not have the case, and this is a very nice approach in the IT, for instance, that you may have one microservice providing function for application X and application Y. Think of it. You have MME, for instance, and you have S gateway and P gateway. The three of them in the packet core, they have components that does the GTP termination or GTP handling, which is the GPRS tunneling protocol. So there are three nodes in your network. They have one function that does GTP handling. So why don't we get this function as a microservice, and it provides services and functions to the other three, or to the three application, MME, S gateway, P gateway. So that's the mindset, that we go to microservice, we decompose the service into microservice, decompose is the right term, and then start using this microservice as a assured exposing capabilities or service to the whole network. You got the idea? So we get a lot of benefits. And here there's one of the well-known pain points. Whenever you do an upgrade or a bug fix, you need to get the downtime and TCN window and whatever, and you may upgrade something in the CNF or the VNF, and it impacts another module, software module. But with microservices, the process now is very confined to the specific microservice. So you do upgrade, you do patching, you do bug fix to the microservice, and this will not impact the serviceability of the other microservice. So you are still under the same CNF, you are still under the same UPF or AMF, but you can now freely work on a specific microservice doing patching and doing this kind of lifecycle management. So it's a very brilliant, plus as an evolution that we reach a stage where we have a set of microservices providing services. That's it. I don't want to go aggressive and say there is no application. For sure, there is an application or a network function, but at the end, you can capitalize on one microservice to serve multiple network functions. It's like now 1 hour and a half, so I will stop and maybe have your reflection and questions and insights.
Hello, Karim. Can you go back to the previous slide where you make, no, the one where you said that this is not a cloud service?
This one?
That one. But do we have something that is cloud native today? I mean, because for example, I have heard from AWS and Google Cloud, whatever, that they cannot migrate easily from one side to the other side, that they have to pay for something. So that means that they are not cloud native, or they are cloud native? Or do we have any cloud native solution today?
Okay.
Either for public or private?
Yeah, that's a very good question. See, Carlo, it's very well known that the cost of migration between public cloud is very high. It's very disruptive. So, and that's why some people say that it's a vendor lock. So you get a cloud native capabilities inside the stack. But if you're thinking of migration, no, you'll suffer a lot. Okay, so the cloud native thing breaks here if you want to migrate out of the cloud. So because there are a lot of dependencies on the cloud itself. Cloud native, yes, the new generation of CNFs that coming from startups and from people actually who are working on cloud compared to the telco vendors, yes, they are cloud native by default. But the only issue here is that with telco, we still tend to put more administration and governance on the placement of the pods and CNFs. So there are still some obstacles not coming from technology, but coming from the organization itself. For instance, if you are a packet core team, and then the cloud will tell you that from now on, you will not know exactly where your pods reside. So you might not accept it. You might not accept that. And you'll tell them, no, I need some dedicated servers in your cloud to host my workload. You got what I want to say, right?
Yes, yes, clear.
Any other questions, comments, reflections? Okay, so I'm not sure if this is a positive thing or negative, but I hope that was informative, and thanks a lot. Next time we will continue. Okay, just I don't want to spend more time than that. I know it's a Ramadan. Most of you are fasting, so let's inshallah have the session next week. Yeah, let's have next week and continue. Thanks a lot.
Thank you, Karim. Thank you so much.
Thank
Thanks
you.
a lot, Karim. Bye.
Thank
Have
you,
a nice
Karim.
weekend.
Bye bye.
Thank you, Karim. Thank you.
Thank you, Karim.
Thank you, Karim.